Hi, I'm Ramzi, and today we're gonna talk about stars' life cycle. It all starts with a cloud of dust and gas called nebula. Over time, the attractive force of gravity pulls more dust and gas together to form a structure called protostar. And as more and more particles collide and join the protostar, it gets bigger and bigger, so its force of gravity gets stronger, which allows it to attract ever more dust and gas. The gravity also squeezes the protostar itself, making it more and more dense. This means that the particles inside it collide with each other more often, which in turn raises the temperature of the protostar. Then, when the temperature is high enough, hydrogen nuclei starts to fuse together to form helium nuclei in a process called nuclear fusion. This gives out a huge amount of energy, which keeps the core of the star hot, and at this point, we call it an actual star, or more precisely, a main sequence star. The outward pressure caused by all of that energy that's being released by nuclear fusion is perfectly balanced by the inward pressure caused by gravity. This allows for a long stable period that can last for billions of years, and it's the stage that our sun is currently in. At some point, though, the star will start to run out of hydrogen, which is effectively its fuel. Basically, this means that the star won't be able to do any more nuclear fusion. And so the inward pressure of gravity takes over and contracts the star into a small ball until it's so hot and dense that nuclear fusion can start up again, which will cause it to expand again. This, though, instead of just forming helium, the nuclear fusion will form a heavier element, including all the elements up to iron in the periodic table. Exactly how much the star expands depends on how big the initial star was. If it was a small to medium star like our sun, it will form a red giant, but if it was a really big star, then it will form a red supergiant. Each of these two types complete their life cycles in different ways. First, the red giant. After a relatively short time, the red giant becomes unstable and expels its outer layers of dust and gas. This leaves behind a hot, dense, solid core which doesn't do any nuclear fusion. We call it a white dwarf. Because it gives off a lot of light, so it appears white and is relatively small. Over time, the white dwarf gets cooler and darker as it emits all of its energy, and finally transitions to a black dwarf, because it no longer have energy to emit light, and so it appears dark. Now, if you go back to our two options for our main sequence star, we get the possibility for the really big stars was to turn into a red supergiant, so let's now take a look at these. Red supergiants actually starts to shine brightly again as they undergo even more nuclear fusions. After passing through several cycles of expansion and contraction, though they eventually explode into something called a supernova, which form elements even heavier than iron that get ejected all across the universe. What happens next? What happens next again depends on how big the star was. If it was just a very big star, then it would condense into a very dense core called neutron star. However, if the star was absolutely massive, then it might collapse in on itself and become a black hole. The reason why we call them black holes is because they are so dense that their gravity is able to pull any light that passes nearby, which means that they literally appear as empty spaces or tiny holes in the universe where no light is ever emitted. To recap everything, stars initially forms from clouds of dust and gas that slowly comes together under the attractive force of gravity to form a protostar. When the pressure and temperature get high enough, nuclear fusion takes off and we transition to a main sequence star. After a long time, often billions of years, the star exhausts its hydrogen supplies and becomes either a red giant if it's a small to medium size or a red supergiant if it's a big star. The red giants throw off their outer layers to reveal a hot dense core that we call it a white dwarf, which then cools to become a black dwarf. Meanwhile, the red supergiant explodes in a supernova, ejecting heavy elements across the universe, and it then condenses into a neutron star if it was only big, or into a black hole if it was truly massive.